Good evening. This is Mr. Wintermelon. So you have learned about cell, as well as how cell take in substances, as well as give out waste. So right now what we are interested is the molecules which the cell take in as nutrient to help to build and grow itself. But before we go into the lesson proper, let us explore this website, which is very interesting. And that is how much of your body is your own. It's from a BBC website, and we can start to explore what are the things or molecules that make up you and me. But of course there are so many of you, so I don't particularly know who to enter. So let's choose a normal one. So let's find the detail of the normal one. Yogan. So Yogan, his birthday is 16th of June. (1967). Sex, how many times a week? Oh, male or female. His height, 1.91 meter, 191 cm. His weight, his mass, weight, 83 kg. So the normal one is 191 cm and 83 kg. So let us look at the elements that make up Yogan clock, the normal one. So for a normal person, 61% of the body will be consist of oxygen, followed by 23% of carbon. So in total, this will already make out 84% plus 10%, 94, plus 3%, already 97%. And the rest will be other elements. So what we are interested in this chapter is mainly concerned with these four elements: oxygen, carbon, hydrogen, and nitrogen, as well as what are the molecules which these four elements are used to make into. You can easily take a guess, why does our body contain so much oxygen and hydrogen? It should be something that you can easily guess. As you ponder about this question, maybe let us sidetrack a bit and discuss where does these molecules all came from? Where are all these molecules made? So these molecules are actually forged in the sun. Not our sun, but a sun that was around, but eventually it died, it burst, and the molecules which the sun were quote-unquote producing get spread across the universe. So in a very poetic sense, we are made up of material that were forged in the sun. We have the sun in us, which is quite cool if you think about it. But now let's get into the proper lesson as to what exactly are the molecules that make up all of us. And they are big connect. No, just kidding. They are biological molecules. And if you are wondering, those are sushi down there. They are not actually biological molecules. They contain biological molecules, but they themselves are not molecules. They are sushi. They are just cute. So I put them there. And as we have just learned, our body are mainly made up of these four elements: oxygen, carbon, nitrogen, and hydrogen. And the question that I left all of you is, what molecules do oxygen, carbon, hydrogen, as well as nitrogen combine into? And what are the importance of those compounds? So this is the main focus of this chapter. What are the biological molecules? And they are Water. So the chemical formula of water is H2O, which means it has 1 molecule of oxygen as well as 2 molecules of hydrogen. But because oxygen is heavier than hydrogen, which is why the mass of the oxygen that make up a human body is more than hydrogen. And our bodies are made up of cells. We learned that cytoplasm is mainly made up of water. Blood contains a lot of water, which is why you see that more than half of our body mass come from oxygen elements, because water is made up of oxygen and our body consists of so much water. Next, we have carbohydrate, fats, and protein. In all honesty, water is not considered a biological molecule, but it is important nevertheless, and more importantly is inside our syllabus, unlike the last biological molecules, which we are not going to talk about in this chapter. It's nucleic acid, by the way. What we are going to focus on is these 4 molecules. What elements are they made up of? Water, all we should know, is made up of oxygen as well as hydrogen. And we are going to learn more about water and its function in this video. Carbohydrate, fats, and protein, we will leave it for the next video. In order to understand the function of water, it's good to know its property. If you have watched some of the previous video, you should have learned that water is dipolar. Dipolar means that one side is partially negatively charged, while the other side is positively charged. Of course, the charge is partial charge. And because of this property, water molecules will form weak hydrogen bond between them. And because of this weak hydrogen bond between water molecules, it gives the water some interesting properties. First, it allows many substances to dissolve. As you have saw in one of the previous video, when we dissolve a substance, the dissolved molecules will be surrounded by water due to this dipolar nature of water. Water have a high specific heat capacity. This is actually a physics term, but without bothering all of you too much with this, basically what this means is it needs a lot of heat energy to increase the temperature of the water. Why is it important? Because our body is made up of mainly water. Having a high specific heat capacity means that we need to absorb a lot of heat before our body temperature is increased. So having a high specific heat capacity will help our body maintain a rather constant body temperature, which allows our body to function effectively. Due to the hydrogen bond, it results in cohesion as well as surface tension, which plays an important role in the transport of water up the stem. And if you do not know, water is less dense in the solid state, which means it floats on water. I think all of you should have seen ice floating on water. And because ice float on water, it allows the organism in a pond to continue living during winter time. Because water allows many substances to dissolve, it allows chemical reactions to take place. Why is it important for things to dissolve before they can react chemically? Because 2 molecules need to come together before they can react with one another. Imagine that there are 2 solid pieces of rock. How are they going to interact with each other if they are in the solid state and unable to move towards each other? Only when they are dissolved, they can float around and come into contact with each other, and a chemical reaction can take place. So water is also the medium to transport all those dissolved substances in plant as well as animal. As I mentioned, they are also key component of our cell. Later on, you will learn about digestive juice as well as other fluid inside our body. It is used to control our temperature, as I have explained. It have a high specific heat capacity. That means we need to absorb a lot of heat before our body temperature increase. Water is needed for photosynthesis. You will learn this in a later chapter. And lastly, it's used to maintain the turgidity of plant, which you should have learned in the previous chapter. This turgidity is important for the opening of stomata, which is important to allow carbon dioxide to diffuse into the leaf so that photosynthesis can take place. So I will end this video here. In the next video, we will learn about carbohydrate, fats, as well as protein.